Design for circularity. Circularity is not sustainability. Sustainability is our destination. It's the broad goal of protecting the planet. Circularity is the specific economic engine to get there. It is not just about doing less bad or being more efficient with a linear take, make, dispose model. It is a restorative system that decouples growth from resource extraction. Textiles are now the fourth highest source of environmental pressure in the EU for water and land use. Currently, every person in the EU consumes about 19 kilograms of textiles a year, but we dump roughly 12 kilograms per person into the trash. Less than 1% of all clothing is actually recycled back into new clothing. To fix this, we must look at the product's life cycle. Up to 80% of a product's environmental footprint is locked in during the design phase. We need to move beyond just choosing recycled fabrics. We must design for molecular circularity, anticipating the end of life at the beginning, choosing polymers and chemical additives that can be recovered without degradation by applying life cycle thinking. The first pillar of circular design is material health, meaning you cannot recycle what is toxic. We must design for molecular safety, choosing dyes and finishes that don't contaminate the biological or technical loops. If a textile contains hazardous chemicals, it's a dead-end material. By selecting safe-by-design inputs, we ensure the material remains a nutrient for the next generation of products. Our second pillar is product circularity. This is where we move from making to engineering. We design for appropriate lifespan, physical durability for heavy-use items, and durability for fashion. But more importantly, we design for disassembly. Using mechanical fasteners instead of permanent glues allows for repair and remanufacturing. As the EEA notes, doubling the life of a product can reduce its impact by nearly 50%. Pillar 3 focuses on the use phase. Digital product passports provide the data needed for repair, resale, and eventually high-quality recycling. We are shifting from selling a product to providing a service. When a designer includes data on fiber composition and care, they are empowering the user to keep that product in the loop longer. The final pillar is material circularity. To avoid the Eurostat 1% recycling trap, we must design for monomateriality or easily separable blends. As ACS research suggests, we need to anticipate chemical or mechanical recycling at the start. If we design with recovery in mind, we can achieve high-value fiber-to-fiber recycling. In Catalonia, the Textiles.cat cluster acts as the catalyst for this change. Their Texar Hub initiative is a perfect example of industrial symbiosis in action. Instead of individual companies struggling with technical waste, the hub creates a shared infrastructure to collect, sort, and valorize scraps. It transforms the linear waste of one manufacturer into the high-performance feedstock for another, keeping value within the local economy. We see these principles come to life with companies like Hilaturas Arnau, who are engineering yarns that are biodegradable by design for technical applications, addressing that material health pillar presented. Or Texsilk, which has mastered the loop by integrating production waste back into high-performance technical fabrics. These aren't just completely free of PFAS fabrics that assure chemical safety, they are resilient business models. According to EEA projections, if we can double our current circularity rate to 24%, we significantly decouple our industry from resource extraction. We aren't just saving fabric, we are slashing the carbon and water footprints of production. By designing for the loops we've discussed, we turn the textile industry from one of the highest environmental pressures into a model of resource efficiency and economic stability. We began by saying that circularity is about doing more good, not just less bad. We've seen that 80% of impacts are decided at the drawing board. The final message is simple. Waste is not an inevitability, it is a design flaw. Through life cycle thinking, molecular safety, and industrial collaboration, we have the tools to fix it. Thank you.